Hello, this is not your chem tutor, and in this video, I will teach you how to convert units using dimensional analysis approach. I have included 6 examples in this video so you can practice dimensional analysis. If you want to convert one unit to another unit, you must follow this format. Given times required unit divided by given unit is equal to answer. This factor in the middle is what we call conversion factor. And how do we know the conversion factor? We must know the equivalence of the two units. If you are not familiar with the equivalence of the two units, then it must be given in the problem. So let's try example number 1. Convert 20 centimeters to meters. So the given is 20 centimeters multiplied to the required unit is meters. The given unit is centimeters. Then look at the equivalence. It says here that 1 meter is equivalent to 100 centimeters. As you can see, centimeters here is on top and centimeters here is on the bottom. When two units are on opposite sides, they cancel out. So centimeters will cancel and we are left with the unit meters. So on top, we have 20 times 1 meter, and on the bottom, we have 100, and this is equal to 20 times 1 divided by 100, that is 0.20, and the unit is meters. So the answer to this question is 0.20 meters. For example 2, let's try the other way around. This time, convert 7 meters to centimeters. The equivalence is 1 meter equal to 100 centimeters. This time, we are given 7 meters. Multiplied to, the required unit is centimeters, and the given unit is meters. According to the equivalence, 1 meter is equivalent to 100 centimeters. Since meter is on top and on the bottom, it cancels out. So we are left with centimeters. So on top, we have 7 times 100 centimeters divided by 1. And 7 times 100, that is equal to 700, and your unit would be centimeters. So the answer is 700 centimeters. Now, some students ask, is it possible that the unit is on the bottom or on the denominator? Well, the answer is yes. And this is the case of example 3. Convert 10 per second to per hour. The equivalence is 1 hour equal to 3,600 seconds. So the given is 10 per second. So as you can see, the unit is on the bottom. Again, the goal in dimensional analysis is to cancel the given unit. So to cancel seconds, you must put the other seconds on top. And you put hour on the bottom. And according to the equivalence, 1 hour is equivalent to 3,600 seconds. So seconds will cancel since they are on opposite sides. So on top, we have 10 times 3,600, and on the bottom, we have 1 hour. If you solve this in your calculator, 10 times 3,600, this is equal to 36,000. per hour. So the answer to this question is 36,000 per hour. For example number 4, we will be converting 2 units. So convert 150 miles per hour to kilometers per second. The equivalents are 1 mile equal to 1.609 kilometers and 1 hour is equivalent to 3,600 seconds. So we are given 150 miles per hour. So we can actually do this 1 unit at a time. So let's convert first miles to kilometers. So we want miles to cancel out. So we put miles on the bottom and we put kilometers on top. So according to the equivalence, 1 mile is equivalent to 1.609 kilometers. So miles will cancel since they are on opposite side. So now we have kilometers. Next, we convert hours to seconds. So hour is at the bottom. So to cancel hour, we put the other one on top. And then seconds on the bottom. And according to the conversion or to the equivalence, 1 hour is equivalent to 3,600 seconds. So hours will cancel since they are on opposite side. And then we have seconds at the bottom. So this is equal to 150 times 1.609 kilometers times 1 on top, and on the bottom we have 1 times 3,600 seconds. And if you solve this in your calculator, 150 times 1.609 times 1 divided by 1 times 3,600, this is equal to 0.0670. We have kilometers on top and seconds on the bottom. So kilometers per second. And this is the answer to the question. For example 5, convert 1.5 years to seconds. So according to the equivalence given, what we can do is to convert first years to days, and then days to hours, hours to minutes, and then minutes to seconds, which is our final unit. So we start with 1.5 years. To convert years to days, you put year on the bottom and on top you put days. And 1 year is equivalent to 365 days. So years will cancel. Now you have days. Then you convert days to hours. You put day on the bottom and on top you put hours. And 1 day is equivalent to 24 hours. So days will cancel and now you are left with hours. And then hours to minutes, you put hour on the bottom and then minutes on top. 1 hour is equivalent to 60 minutes, so hours will cancel out. And finally, minutes to seconds, you put minute on the bottom and on top you put seconds. 1 minute is equivalent to 60 seconds, so minutes will cancel and our final unit would be seconds. So on top, we have 1.5 times 365 times 24 times 60 times 60 seconds. And on the bottom, we have 1 times 1 times 1 times 1. So 1.5 times 365 times 24 times 60 times 60 seconds, that is equal to 0.0821. For the last example, convert 0.0821 liter atmosphere per mole Kelvin to calories per mole Kelvin. So in this case, we only need to convert the units on top from liter atmosphere to calories. No need to convert the units on the bottom because they're both mole Kelvin. So we start with 0.0821 liter atmosphere per mole Kelvin. So what you can do is to convert first liter atmosphere to joules. So you put liter atmosphere on the bottom and on top you put joules. So 1 liter atmosphere is equivalent to 101.325 joules. So liter atmosphere cancels out. Now we have joules. And then you can convert joules to calories. So you put joules on the bottom and calories on top. 1 calorie is equivalent to 4.184 joules. So joules cancels out, and your final unit would be calories on top, and then on the bottom you have mole Kelvin. So this is equal to, on top we have 0.0821 times 101.325 times 1 cal, and on the bottom we have mole Kelvin times 1 times 4.184, and if you solve this in your calculator, you will get the answer 1.988, and the unit would be calories on top and mole Kelvin on the bottom. So cal per mole Kelvin. And this is the answer to the question.